The Mystery of Gravity and the New Paradigm, presented by L.S. Larkey and the Unified Theory of U. Gravity has long been one of the most intriguing and fundamental forces in the universe. From the moment an apple fell from a tree, leading Sir Isaac Newton to formulate his groundbreaking theory, to the modern era of Einstein's general relativity, gravity has remained at the forefront of scientific inquiry. Yet, despite centuries of study, gravity still harbors mysteries that challenge our understanding of the cosmos. Newton's law of universal gravitation posited that every mass attracts every other mass with a force proportional to their masses, and inversely proportional to the square of the distance between them. This elegant equation allowed humanity to predict the movements of celestial bodies and understand the force that keeps us anchored to Earth. However, as our observational tools and theoretical frameworks have advanced, so too have the questions surrounding gravity. Einstein's theory of general relativity revolutionized our understanding by describing gravity not as a force, but as a curvature of space-time caused by mass and energy. This theory successfully explained phenomena that Newtonian mechanics could not, such as the precession of Mercury's orbit and the bending of light around massive objects. Yet even general relativity leaves certain questions unanswered, particularly when it comes to the behavior of gravity at quantum scales, and within the context of dark matter and dark energy. The journey to understand gravity spans millennia, beginning with the ancient Greeks, who speculated on the nature of attraction and motion. Aristotle believed that objects had a natural place in the universe and would move towards it. But it wasn't until Newton that a quantitative description emerged. Newton's work in the 17th century provided a robust framework that described gravity as a force acting at a distance, explaining the orbits of planets and the trajectory of projectiles. The 19th and early 20th centuries saw the rise of new questions as physicists observed anomalies in Mercury's orbit that couldn't be explained by Newtonian mechanics alone. This led to the advent of Einstein's general relativity in 1915, which described gravity as a warping of space-time itself. This theory has been confirmed by numerous experiments and observations, including the famous Eddington expedition of 1919, which observed the bending of starlight by the sun during a solar eclipse. Despite its successes, general relativity struggles to reconcile with quantum mechanics, the framework governing the subatomic realm. The quest for a quantum theory of gravity has led to numerous hypotheses, including string theory and loop quantum gravity, yet none have been conclusively proven. Additionally, the discovery of dark matter and dark energy substances that appear to make up most of the universe's mass, energy content but do not interact with light, has posed new challenges, suggesting that our understanding of gravity is still incomplete. While both Newtonian gravity and general relativity have provided profound insights into the nature of gravitational forces, they also have their limitations. Newton's theory, for instance, fails to explain the intricacies of gravitational interactions on cosmic scales and at relativistic speeds. General relativity, though more comprehensive, cannot be easily integrated with quantum mechanics, leading to inconsistencies when describing gravity at the smallest scales. One of the most pressing issues is the nature of dark matter and dark energy. Observations of galaxies and cosmic microwave background radiation suggest that ordinary matter makes up only a small fraction of the universe's total mass and energy. Dark matter, which does not emit or absorb light, seems to exert gravitational forces that affect galaxy rotation curves and large-scale structure formation. Dark energy, on the other hand, is proposed to drive the accelerated expansion of the universe. However, their exact nature remains elusive, and current gravitational theories do not adequately explain them. Moreover, phenomena such as the anomalous rotation curves of galaxies, gravitational lensing effects, and the distribution of mass in galaxy clusters suggest discrepancies that neither Newtonian gravity nor general relativity can fully account for without invoking unseen substances. In light of these challenges, new theoretical frameworks are needed to advance our understanding of gravity. One such promising avenue is the unified theory of U, which proposes a novel approach to gravity involving the subtle magnetic field, SMF, and the relative vacuum of space, RVS. By re-examining gravity through the lens of these concepts, we may uncover deeper truths about the nature of the universe and address the limitations of current theories. This book aims to explore these ideas in depth, offering a fresh perspective on one of the most fundamental forces in the cosmos. All theoretical paradigms regarding gravity presented herein are copyrighted by Atlantean Astrology, LLC, and L.S. Larkey through the book The Unified Theory of U. Any reproduction, distribution, or use of these concepts without explicit permission from the copyright holders is strictly prohibited. This protection ensures the integrity and originality of the innovative approaches to understanding gravity as detailed in the publication. The concept of the subtle magnetic field, or SMF, is pivotal to the unified theory of U, offering a new lens through which to understand gravitational and cosmic phenomena. The SMF is not merely an extension of traditional magnetic fields, but a unique, pervasive force that originates from beyond the 10th dimension. This field interacts dynamically with the relative vacuum of space, creating a framework that can explain a wide range of cosmic behaviors and structures. In classical physics, magnetic fields are generated by moving electric charges and are described by Maxwell's equations. However, the SMF is fundamentally different. It is a manifestation of consciousness and energy from higher dimensions, permeating the universe and influencing the physical realm in profound ways. Unlike traditional magnetic fields, the SMF is not confined to the interactions between electric charges, but is instead an inherent property of all sentient beings and celestial bodies, acting as a bridge between the material and higher dimensional realities. The SMF emanates from the higher dimensions, specifically beyond the 10th dimension, where consciousness and energy converge to create a force that can influence the physical world. This field is a projection of consciousness, capable of interacting with the fabric of space-time and the RVS. The interaction between the SMF and the RVS generates a dynamic pressure that shapes the behavior and structure of celestial bodies, from planets to galaxies. In this framework, the SMF can be visualized as a pulsating force, akin to the heartbeat of the universe. Just as the human heart creates a magnetic field that extends beyond the body, the SMF extends throughout the cosmos, influencing the motion and formation of celestial objects. This pulsating nature of the SMF can be thought of as the universal constant, similar to the speed of light, governing the dynamics of the universe. The SMF is inherently tied to the concept of consciousness. It is through the projection of consciousness that the SMF manifests in the physical world. This means that every sentient being, including planets and stars, has an inherent SMF that interacts with the RVS. The strength and influence of this field depend on the level of consciousness and the interaction with the surrounding environment. The interaction between the SMF and the RVS is fundamental to understanding how this field influences the universe. The RVS, or relative vacuum of space, is not a true vacuum, but a region where the pressure varies depending on the presence of magnetic fields and celestial bodies. The SMF creates a bubble within the RVS, with the pressure of the vacuum acting upon this bubble to maintain its shape and stability. This interaction is crucial for explaining gravitational effects in the unified theory of U. Traditional theories of gravity, such as Newtonian mechanics and general relativity, attribute gravitational forces to the mass and curvature of space-time. In contrast, the unified theory of U posits that gravity is a pushing force resulting from the pressure differential created by the SMF within the RVS. As the SMF interacts with the RVS, it generates a force that pushes objects towards regions of higher pressure, creating the effects we observe as gravity. This new understanding of gravity can explain various cosmic phenomena that traditional theories struggle with. For instance, the anomalous rotation curves of galaxies, which suggest the presence of dark matter, can be explained by the varying intensity of the SMF and its interaction with the RVS. In regions where the SMF is stronger, the pressure differential increases, creating a more substantial gravitational effect without the need for unseen mass. Moreover, the SMF can account for the structure and formation of galaxies. As protogalactic clouds interact with the SMF, the dynamic pressure within the RVS shapes these clouds into the rotational structures we observe today. This interaction can also explain the stability of galactic formations over billions of years, as the SMF continually maintains the pressure differential necessary for their coherence. The SMF's influence extends to smaller scales as well. On planets like Earth, the SMF is responsible for the magnetic field that protects the planet from cosmic radiation and solar winds. This field, generated by the planet's core, interacts with the RVS to create a stable environment that supports life. Similarly, the SMF of stars, such as the Sun, governs their magnetic activity and influences the behavior of their solar systems. The implications of the SMF are vast and transformative, offering new ways to understand and interact with the universe. One of the most significant applications is in the realm of space travel. By harnessing the principles of the SMF, it may be possible to develop propulsion systems that operate by manipulating the pressure differentials within the RVS. This could lead to faster and more efficient space travel, enabling humanity to explore distant stars and galaxies. In the field of medicine, understanding the SMF can lead to advancements in health and healing. Since the SMF is tied to consciousness, techniques that enhance and focus this field can promote physical and mental well-being. Practices such as meditation, energy healing, and advanced medical technologies could be developed to align the human SMF with the universal field, leading to improved health outcomes. The study of the SMF also opens new avenues for scientific research. By developing technologies that can measure and manipulate the SMF, scientists can gain deeper insights into the fundamental nature of reality. This could lead to breakthroughs in physics, cosmology, and other scientific disciplines, ultimately expanding our understanding of the universe and our place within it. In conclusion, the subtle magnetic field is a revolutionary concept that redefines our understanding of gravity and cosmic phenomena. By integrating consciousness and higher dimensional interactions, the SMF provides a comprehensive framework for exploring the mysteries of the universe. As we continue to investigate and apply the principles of the SMF, we may unlock new potentials for humanity and transform our understanding of the cosmos. The Mystery of Gravity, Chapter 2 by L.S. Larkey and the Unified Theory of You. All theoretical paradigms regarding gravity presented herein are copyrighted by Atlantean Astrology, LLC and L.S. Larkey through the book The Unified Theory of You. Any reproduction, distribution, or use of these concepts without explicit permission from the copyright holders is strictly prohibited. This protection ensures the integrity and originality of the innovative approaches to understanding gravity as detailed in the publication. The concept of the relative vacuum of space, or RVS, is integral to the unified theory of you. Unlike the classical notion of a vacuum as an empty void, the RVS is dynamic, influenced by varying degrees of vacuum pressure and shaped by the presence and interaction of the subtle magnetic field, or SMF. This chapter explores the nature of the RVS, its interaction with the SMF, and the significant role it plays in shaping the cosmos. Traditional physics views space as a near-perfect vacuum, with minimal matter and energy. However, the RVS acknowledges that vacuum pressure can vary based on the presence of magnetic fields in celestial bodies. This variability creates a complex and dynamic environment where the interactions between the SMF and the RVS drive many of the phenomena we observe in the universe, from the formation of galaxies to the behavior of planetary systems. The RVS can be understood as a field of variable vacuum pressure that permeates the universe. This pressure is not constant but changes depending on the density and strength of the SMF in different regions. The interplay between the SMF and the RVS creates zones of high and low pressure, which in turn influence the movement and formation of celestial bodies. One of the key features of the RVS is its ability to respond to the presence of the SMF. When the SMF permeates a region of space, it creates a pressure differential within the RVS. This differential acts like a force, pushing objects towards areas of higher pressure. This is fundamentally different from the classical view of gravity as an attractive force between masses. In the unified theory of U, gravity is a pushing force resulting from the pressure exerted by the RVS in response to the SMF. This dynamic interaction can be visualized by considering a cosmic bubble analogy. Imagine a bubble in water, where the water pressure keeps the bubble in a stable shape. Similarly, the RVS exerts pressure on the SMF, maintaining the stability and structure of celestial bodies. This pressure is not uniform and can vary significantly across different regions of space, leading to diverse gravitational effects. The interaction between the SMF and the RVS is fundamental to understanding many cosmic phenomena. One such phenomenon is the formation and structure of galaxies. In the traditional view, galaxies form through the gravitational collapse of matter in the early universe. However, the unified theory of U proposes that the SMF emanating from protogalactic clouds interacts with the RVS to shape the rotational dynamics and structural formation of galaxies. As protogalactic clouds with strong SMFs form, they create pressure differentials in the surrounding RVS. These differentials influence the movement and aggregation of matter, guiding the formation of spiral arms and other galactic structures. The SMF ensures that the galaxies maintain their rotational dynamics over billions of years, with the RVS acting as a stabilizing force. Another significant implication of the RVS is its role in planetary systems. Planets are born from the interaction of the SMF with the RVS. When a new SMF penetrates the RVS, it creates a bubble of higher pressure that gradually materializes into a planetary body. This process can be likened to the formation of a soap bubble, where the balance between internal and external pressures maintains the bubble's structure. The RVS also influences the behavior of celestial bodies that do not emit strong SMFs, such as dwarf stars or the Moon. These objects experience gravity as a result of the pressure exerted by the RVS in response to their presence. Unlike objects with strong SMFs, which create significant pressure differentials, these celestial bodies experience a more gradual gravitational push as they interact with the RVS. Understanding the RVS opens new avenues for research and technological advancement. One potential application is in the field of propulsion systems for space travel. By manipulating the pressure differentials within the RVS, it may be possible to develop propulsion technologies that are more efficient and capable of faster interstellar travel. This could revolutionize our ability to explore distant regions of the galaxy and beyond. The study of the RVS also has implications for our understanding of dark matter and dark energy. Traditional cosmology posits the existence of dark matter and dark energy to account for the missing mass and the accelerated expansion of the universe. However, the unified theory of U suggests that these phenomena could be explained by the dynamic interactions between the SMF and the RVS. Further research into the RVS could provide new insights into these mysterious aspects of the universe. Moreover, the RVS has implications for our understanding of consciousness and its role in the cosmos. Since the SMF is a projection of consciousness, the interaction between the SMF and the RVS suggests that consciousness itself plays a fundamental role in shaping the universe. This perspective opens new questions about the nature of reality and the interconnectedness of all things. In conclusion, the relative vacuum of space is a crucial component of the unified theory of U, offering a new framework for understanding gravity and cosmic phenomena. By exploring the dynamic interactions between the SMF and the RVS, we can gain deeper insights into the nature of the universe and our place within it. As we continue to investigate these concepts, we may uncover new principles that will transform our understanding of the cosmos and lead to groundbreaking advancements in science and technology.